Hey, and welcome to 8.6. Today we're going to be graphing tangent functions. Tangent functions are the third of the trig ratios that we're going to be graphing. And we're going to notice that the tangent function is going to be a little different than the sine and cosine. It's not going to be continuous because as we work our way around the unit circle, tangent is going to be opposite divided by adjacent, or that y value divided by the x value. And when we get to the top and the bottom of our unit circle as we rotate around, our x value, or our adjacent side at the very top, goes to 0. So we're not going to be able to take that radius, which is a radius of 1, and divide it into something that doesn't exist. We can't use that in normal real numbers in algebra. So let's take a look at what that would look like when we approach those values of infinity. So 8.6, what we're looking at is we're looking at graphing tangent waves. So tangent waves, like sine waves, we're going to have to go through the unit circle using those special right triangles. So let's take a few things that we're going to be seeing here in tangent waves. The first thing is tangent waves contain asymptotes. And we'll see that here in a minute. And that's because of the relationship between the legs of the triangle. Okay, so one of the ways that we can look at that is if we remember the fact that the legs of a triangle are the two sides adjacent to the 90-degree angle. A tangent of any angle is going to be the opposite over the adjacent, which for the unit circle is going to be our y value over our x value. And the asymptotes, things that it can't equal, is when that unit circle finally approaches a 90-degree position because it's y divided by x. And what happens when the x is squished all the way down to where there is no x? Can we take 1 and divide it by 0? No. So it's going to give us an asymptote. So our whole idea is, what do we do when we see something like that happens? So let's go ahead and let's take a look at our first example. Okay, so when we're graphing y equals the tangent of x, our first job is we're going to build an xy table. So x, y. And we're going to start our first table. Now, we've got a couple special relationships, so let's do the fastest one, kind of like what we're doing in the last section, where I go through 0, 45, and 90, and just every unit of 45. And the other thing that we can do is if we don't like degrees, we can also list this in radians. So I'm going to put the comparable radians off to the side. Okay, so we have both degrees in black and we have radians in purple. And if we remember, when we're graphing the tangent of y, we're consulting the special right triangle, which is a 45, 45, 90 triangle. And we're going to be flipping this one end over end. I know with a radius of 1, and this is going to be the square root of 2 over 2, square root of 2 over 2. Tangent is going to be opposite over adjacent. So with 0 degrees, this is fully flat. Y doesn't exist, so I have a y value of 0. 45, I take this and divide it by itself, which is going to give me a 1. And at 90 degrees, that radius is fully up. I do not have an x to divide by, so I'm taking 1 and dividing it by 0, which can't get me anything other than an infinity. And then as I flip this triangle onto the other side, it's the same thing, just facing the other direction. Square root of 2 over 2, square root of 2 over 2. The only difference here is this negative sign. So I know the fact that I get a negative 1. And as it folds all the way down, I get a 0. And as it folds beneath the line, I have that same triangle yet again. It's facing upside down. So negative square root of 2 over 2, negative square root of 2 over 2, 1. So if I have a negative divided by negative, it's going to give me a positive 1. And as that swings full circle, my radius is 1, but the x has collapsed again. I get another infinity. And this pattern repeats itself. 0, 1, infinity, negative 1, 0, 1, infinity, negative 1, 0, 1, infinity. And we could keep going on and on. But let's see what this graph looks like. So what we've done here is we've listed the x-axis out in degrees. Now I could have listed it out in radians as well, but we're going to list degrees because I think it's a more introductory concept. And let's go ahead and let's graph these points. So at 0 I have 0, at 45 I have 1, and at 90 it's going all the way up to infinity. I have negative 1, 0, 1, infinity. Negative 1, 0, and then I would have another 1 and infinity going off to the right. So what it looks like this is doing is this is going straight towards infinity. But now realize infinity doesn't exist just right here. Infinity is all the way up on my graph. So I'm going to have to put a little bit of an inflection to say, hey, curving upwards towards infinity. And at this point right here, I know that x can't equal 270 degrees, or we could just say x can't equal 3 pi over 2 radians, however you want to list that. Same thing right here. It's going to curve up. We're going to add an inflection so that we're actually approaching generalized infinity. And we know that right here, x can't equal 90 degrees, or if that was in radians, that would be pi over 2 radians. And so if the graph is curving up towards infinity, what's it look like it's doing over here as it goes towards this asymptote from the right-hand side? Well, it's doing the same thing. It's curving towards infinity, but in the downward direction. So we can repeat that over here as well, curving towards infinity in the downward direction. And that's our tangent function. Now, let's say we didn't pick the 45, 45, 90. Let's say we picked the 30, 60, 90. What would happen if we did that? So let's graph that same graph, but we're going to graph it with the 30, 60, 90 and see if we get the same thing. So we're going to graph y equals the tangent of x. We're going to graph with x, 30, 60, 90. Okay, all I could go down to was 300. But we know the fact that it's probably going to repeat itself just like it did up there. And if we wanted to, we could list this in radians. Okay, so we have it listed in degrees and in radians. And let's see what the graph looks like in this general direction. And so when we actually fill out this graph, instead of using the 45, 45, 90, we're dealing with the 30, 60, 90. 30, 60, 90. And we know that its special values are going to be 1, 1/2, and the square root of 3 over 2. And so as we work our way up, we know our first y over x is going to be at 0 degrees, we don't have a y value. So we have 0. At 30 degrees, we're going to have 1/2 divided by the square root of 3 over 2, which we could say, okay, it's actually 1/2 times 2 over the square root of 3, which is going to give us 1 over the square root of 3, or roughly 0.57. If we do the 60 degrees, basically we've flipped this triangle around, and we're saying from this angle, what's the tangent? Square root of 3 over 2 divided by 1/2. Square root of 3 over 2 divided by 1/2, or times 2 over 1. It's just the square root of 3, which is roughly 1.73. And so we know that with each 30, 60, 90, it's going to be some variation of these, maybe positive or negative. As we hit 90, we're taking that y value, which is going to be 1, divided by an x that doesn't exist. So there's our infinity again. At 120, we know we're dealing with a 60 degree from our flat line right there, which is going to be negative 1.73. We get a negative 0.57. At 180, we're going to be back to 0, and we have completed the loop. Now we're just going to start cycling through these values. So 0.57, 1.73, and infinity. And at 270, we can check ourselves. At the bottom position, our x value doesn't exist, so our y value is 1 divided by 0. We're good. What comes after infinity? Or negative 1.73. And so let's go ahead and graph those. So now I have 0, 0.57, 1.73, and infinity. So I have something that it can't touch. I have negative, and there we go. So we see again it's curving upwards towards infinity, where I have an asymptote where it's never actually going to reach it because we can't divide 1 by 0. And the same thing is going to happen over here, except for it's going to approach negative infinity off towards the right. And over here we just have a little piece of our graph, and that is what the tangent function looks like. Okay, so we saw that we graphed tangent functions, and we noticed that when we approached that value of x equaling 0 and we tried to divide into there, we couldn't get it, and it looked like an infinity. We saw that the graph curved upwards towards that value and downwards towards that value on each side, but it was discontinuous because it didn't approach from the same orientation. It went up to infinity, and then it continued on as though it came up from a negative infinity on the bottom of the graph. And we noticed that those intervals were very even. And it was about every pi lengths we approached another asymptote. So that's it for 8.6. If you have any questions, let me know.